So in this problem, they give us another car depreciation example, except that now they've only given us these two data points. After 3 years, the value is 12.5 thousand. After 7 years, the value is 6.5 thousand. And we're supposed to come up with an exponential model for this. Right? And so the first approaches that I've seen you using in your groups is by taking the template for an exponential function, v equals a times b to the t, plugging in both of my data points. So when t is 3, v is 12.5. When t is 7, v is 6.5. And now I have two equations and two unknown quantities, a and b. Right? So hopefully that's enough information to tell me what a and b are. The problem is we want to eliminate a variable. We want to get this down from having two variables into just having one so that we can solve for it. So how can I take these two expressions, a b to the seventh, a b to the third, what can I do with those two that will permit me to cancel one of the variables? Divide. Divide either of them by the other. What am I going to be able to cancel? The a's. So I'm just going to divide a times b to the seventh divided by a times b to the third. And now you can see why we did exponent gymnastics as part of our first algebra workshop, right? Because now my a's are gone. And how many b's do I have left over? 4 of them. 7 minus 3. Right? So my new right-hand side is just b to the power 4. But if I do that with these two quantities, I know those quantities each by another name as well. A times b to the seventh I know by the name 6.5. This I know by the name 12.5. So what does b to the fourth equal to? 5.2. Yeah, 6.5 divided by 12.5. Which we carry out that arithmetic. That gives us 0.52. 0.52. Not a very good looking 0.52. There we go. So I want to pause right here and ask, what is this number 0.52 telling me about my car? So in year 3, my car was worth 12,500. In year 7, it's worth 6,500. So at the end of that 4-year period, I have kept 52% of the value of my car. So how much of my value of my car have I lost in that amount of time? 48%. So minus 48% over those 4 years. Right? So my car is depreciated by 48% over those 4 years. And that is the right kind of thinking if we're trying to set ourselves up for this to be an exponential function. Right? We want to be comparing my independent variables by adding and subtracting. So 4 years. Why do we know it was 4 years? It was 7 minus 3. Right? It's an additive subtractive comparison. Right? So we think of the difference between 3 and 7 here as being addition, plus 4. But we think of the difference between 12.5 and 6.5 as being a difference that we measure by multiplication and division, times 0.52. Oops. Right? Okay, but we're not done yet, because that doesn't tell me what b is. That tells me what b to the fourth is. So how do I solve this equation for b? Yeah, I just want to take the fourth root of both sides, the quartic root of both sides. What's another way to say that? What is taking a fourth root the same as using to the power 1/4? Exactly. Most calculators don't have a 1/4 root button, but they do have an exponent button that lets us raise 0.52 to the power 1/4 and then solve for b. It's the fourth root of 0.52. And what is that approximately?
0.849.
Let's call it 0.85, just round it up to percentage. There we go. Great. So now we have a value for b, 0.85. Let's go put that into our formula. 0.85 to the power t. And now that we know that, we can use that to find a value for a. But I actually want to pause here real quick, because I want to ask, what's the meaning of this number? What is that 0.85 actually telling me?
Is that how much it's depreciating by?
That's how much it's depreciating by over how much time? 1 year instead of 4 years. Exactly. So over the course of just 1 year, how many percent value is my car losing? 15. Yep. So when the number of years goes up by 1, the value of my car goes down by 15%. So times 0.85. And that number, 0.85, that's what we call the base of this exponential function. Right? The base of an exponential function is an answer to the question, every time my independent variable increases by 1, by what number is my output variable being multiplied? Right? Every time I plus 1 to my input, I multiply by 0.85 to my output. And so that number tells me the base. Now, just to wrap this up, how do we find this value for A? Yeah, we can plug any point in. This is just like when we're using the y equals mx plus b template, and we know the slope. We find the slope first, and then we plug in one of our points to find the value for b, the intercept. Same story here. We found the base first, which is the analog here of slope, right? It's a measurement of the consistency of the changes from one point to the next. And then once we've found that base, plug in any of our points to find the value for the other parameter a. Let's use maybe this point here just because it has the smaller t value. So if t is 3, then that means that v is 12.5. And we get 12.5 equals a times 0.85 to the power 3. And so a is nothing more than 12.5 divided by 0.85 to the power 3. Something doesn't quite seem. So we do that out, we get 20.354. And so now, I want to ask, what's the meaning of that number?
That's what it starts with.
That's the amount of value that my car here starts with. 20.3. Or 20.4, however you want to round that, right? And so where in my data table does this number belong?
0.
At t equals 0. So in fact, this is exactly the vertical intercept of this graph, right? Just like b for a linear function was the vertical intercept of a linear function, the a here that plays this role in the exponential function formula is a vertical intercept for that function. So the meaning of that a parameter here is just, it's the value of v, the value of my output, when the value of my input is 0. That's why it's the vertical intercept.